Hello good to everyone. Today, I will discuss what is breadth first search. Breadth first search is one of the topic in data structures and algorithm. But before we're going to the topic, I would like to introduce myself. I am Miki Jean Calyao together with my group members.
I am Elaine May Cabunok.
And I am Jamie Mayola.
We have here some objectives. The first one is introduction of the breadth first search. The second one is explain the discussion, and the last one is explore the simulation. Breadth first search is an algorithm used for traversing or searching a tree graph or graph data structures. Is a method exploring a tree graph. In breadth first search, you first explore all the nodes one step away, then all the nodes two step away. It starts at the root node or any node you choose in the graph. Explore all the neighbors at the current depth before moving on the nodes at the next depth level. Repeat the process for each node you reach, working your way outward from the starting point. For the continuation of the discussion, Miss Elaine will continue.
What is breadth first search? Breadth first search, or BFS, is an algorithm for traversing or searching tree or graph data structures. It starts at the tree root and explores the neighbor nodes first before moving to the next level neighbors. The breadth first search, or BFS, algorithm uses a queue data structure to keep track of the vertices that need to be examined. It follows the FIFO principle, or the first in, first out principle, where the element that is inserted first is the first one to be removed. BFS uses a queue to keep track of the nodes to be explored. It increases the root node and then decreases. Big O notation V plus E is a time complexity of the BFS algorithm, where V is the number of the vertices and E is the number of the edges in the graph. So this is the steps in implementing BFS algorithm. First, initialize a queue and a visited array. Second, add the source vertex to the queue and mark it as visited. Third, while the queue is not empty, remove the front vertex from the queue. Fourth, add the adjacent vertices of the removed vertex to the queue if they have not been visited before. Fifth, mark the removed vertex as visited. And lastly, repeat steps 3 to 5 until the queue becomes empty. To understand it further, here are the simulation of breadth first search algorithm.
Welcome to the breadth first search algorithm simulation. Today, we'll take a visual journey through exploring of a graph using breadth first search. An example. Let's take a look at the graph. We will use the breadth first search algorithm to traverse through the graph. First, we need to take an empty queue. We will use this queue to keep record all the unvisited node of the currently working node. Let's starting from a node A. In queue node A into the queue and mark it as visited. So A is already visited. We need to dequeue node A and equeue its neighbors node B and C. Then mark them as visited. B is already visited. We need to dequeue node B, Then in Q, its unvisited neighbors node D and E. Then mark them as visited. So C is already visited. We need to DQ node C, and then in Q its unvisited neighbors node F and G. Then mark them as visited. Continue this process till the queue is empty. Now, the queue is empty. So the output we have A, B, C, D, E, F, and G. The resulting in time complexity V is equal to 6. V means the number of vertices. Then E equals 7. Then E means edges in the number of graph. So this is the result of time complexity.